All right, so my goal is to talk about some of the mysteries about the main program for PA3, because we've talked a lot about the hash functions and the linked lists and all that, but people are probably at the point where they're wiring up main programs, and there's some confusing aspects to that. So let's talk about main program. And I guess pseudocode wise, here's what I think of for PA3. First thing I want to do is check and process command line arguments. They need to specify a database name. They can optionally specify a size for the hash table. And they're not allowed to do anything else. So, database name and hash size. And then, assuming that all of that's legal, I want to initialize a hash table with that given hash size. And then I want to open the database file, right, using whatever name I got, and read a line and add it to the hash. And I'm going to do that in a loop. And then when I'm done reading the database file, I've got my hash of the license plates fully built. I'm going to read a user input. I'm going to process it. And I'm going to loop at that for a while until the person hits Control D. And then I'm going to free my memory and get out of here. So that's a high-level view of what PA3 is going to be, right? Process command line arguments, initialize my hash table, open up the database file, read the information in from there and store it in the hash table, and then process user commands using that hash table. And when the user's done, free up my memory and leave. So let's work through this. So if we're going to do command line arguments, we got to have two arguments for main: a character and an integer and a char star star. So argc, char star star, argv. And the first thing I'm going to do is try to figure out what argc should be. So I'm just going to print it. Okay, between bash and C, there's differences in the meaning of argc, or that first argument. And it's been a while, so I'm not going to try to remember this. I'm just going to print out the value of argc. And I'm going to call this plate.c. And I'll compile it up as plate. Okay, so here's some of the things that can happen. The user might just say plate. That's an error. They need to specify a database. If they just say plate, argc is equal to 1. So argc equals 1. They just said plate. I'm just writing this down. Okay, if they say plate and they put in the name of a database file, argc is 2. And you know, if they type in the name of a file that doesn't exist, argc is still 2. It's not telling me if that's a good file, it's telling me how many things are on the command line. And if they type in a hash size afterwards, argc is 3. And if they type in extra stuff after that because they're really ambitious, argc is 4 or 5 or more. So I have a little template here for how to do my syntax checking on the arguments. If argc is 1, that's an error. If argc is 2, this is going to be the database name. If argc is 3, this will be the database name, and that'll be the size. If argc is bigger than 3, that's an error. All right, so let's code that. Check the number of the arguments. If argc is not 2 and it's also not 3, they didn't call the function correctly. Right? They didn't do what I was expecting them to do. And so I'm going to print out a message which says usage, and I'm going to tell them how they should have used this command. Plate, followed by the database, and then followed by size and brackets. When you put a usage message and something's in brackets, you're saying it's optional. Okay, that's just a standard Linux thing. So they could run this in either that way with a database or a database followed by a size. And I'm just going to return here. And I'm going to get rid of my print down here. So if I just say plate, I get a usage message. If I use it like that, it's fine. If I do extra stuff, I get a usage message. Now if I change the name of my program to main, and I run main, it still tells me usage plate, database, optional size. Well, I didn't run the plate command, I ran a command called main. That's a little awkward, right? So here's something we can do inside plate.c. Instead of saying in my usage message that they should say plate, I'm going to make that a %s, and I'm going to print out argv bracket 0. Why? Because argv bracket 0 is the name of the program. Okay, so this will print usage followed by the name of the program that they just ran, followed by the word database, followed by the word size in brackets. So if they run plate, it'll give them a message like that. If someone decides to change the name of this program to main, and they run main, it says, oh, you should have said main followed by a database. Okay, it's just a little nicety thing. So it doesn't make the name of the program fixed. Yeah?
Do we need to do the usage statement, or do we need to do an error?
I think I just said throw an error, right? Yeah, that's fine.
Okay.
Yeah, we're going a little above and beyond here. All right, so, and I'm returning right there, okay? So, so if I get past that if statement, we got the correct number of arguments. Okay, let's figure out what the hash size should be. Well, if argc is 2, we know argc is 2 or 3. If it's 2, they didn't specify a database size, a hash table size. If argc is 3, they specify the size down here. So let's take advantage of that. It would think that that was the database.
Oh,
yeah.
Sure. I mean, could you have a database name like file?
You could, yeah. It's a legal file name. All right, so if argc is equal to 3, I'm going to scan. Yes?
You need to initialize size?
I do. If argc is 3, I'm going to scan argv bracket 2. So this is argv bracket 0 is the file name, bracket 1 will be the database, bracket 2 will be the size, but only in the case where argc is equal to 3. If argc is equal to 3, what's bracket 2? It's null. If I try to scan it, I seg fault. So I'm going to scan argv bracket 2 into size, and I need to declare size. And then let's print out the size as an integer. So if I say 250, it tells me the size is 250. If I say ha ha, it tells me the size is 32766. If I don't catch that, I'm going to make a really big hash table with 32,000 linked lists in it. And it's going to do weird things, and I'm going to have no idea why it's doing these weird things. Okay, so what's missing here? How can I tell that my size is not supposed to be 32766?
A extra buffer that can detect whether or not it's got non-numeric characters.
Right. So we want to know, did it convert argv bracket 2 to an integer? Right? Did it actually find an integer there? That's what the return value from sscanf will tell us. So we're asking it to convert one thing, an integer, that's the %d, and we're asking it to store one thing, that's an integer value in size. If it succeeds in doing that, sscanf will return a 1. So if sscanf returns a 1, then I know that it succeeded. And I can do whatever I want to do. Well, if it returns a 1 and it succeeds, I want to do everything else in PA3, right? So if I put a curly bracket over here, I'm going to have the rest of my program inside a curly bracket. I don't like curly brackets that much. I like them sometimes. But here's what I'm going to do. I'm going to say if it's not equal to 3, then there's a syntax error. I'm like killing my CPU. Or killer load average. Okay. So if the scanf does not return a 1, they did not type in a valid integer. So I'm going to print an error message and say whatever argv bracket 2 was is not a valid integer. And I'm going to return. Otherwise, they specified a valid size, and I'll print out what the size is. But that should have been a %s, because argv bracket 2 is a string. Okay, so if they say plate database.txt 300, tells me size is 300. If they say haha, it'll tell me haha is not a valid integer, and I'll exit.
So it actually converted into an integer, but it won't register that.
No, it doesn't convert it actually. It leaves that integer value unchanged.
Oh,
So size is just whatever value it happened to be.
I see.
Okay, so what am I doing here? I am trying to implement my pseudocode, right? And I'm working on this check and process the command line arguments, figure out what the database name is, figure out what the hash size is. And then I'm going to go ahead and call hash init, okay? So the database name is going to be argv bracket 1, okay? That's what I got here. So I can note that. hash size is just going to be size. I'm still laggy. I don't know what else is running. Database name is argv1, hash size is size. So let's print those. Let's print out the database name, let's print out the hash size. Okay, database name is that, hash size is 200. If I don't specify a database size, a hash table size, my size is something weird. 32767, or maybe something close to that. So what's the problem? Well, the only time I do this sscanf to give a value to size is if argc was equal to 3. If argc was equal to 2, they specified a database but not a size. And I never gave size a value. So I could say if argc is equal to 2, set size equal to 100. Or I could say, you know, if argc equals 3, do this, else set size equal to 100, right? Or I can do the easiest of all and just initialize it to 100. So this is the default hash table size. If they specify a number, it'll get overwritten down here in this sscanf. Otherwise, by the time I get down here, size will just be the value that it started off as, which was 100. So if I don't specify a size, it's 100. If I do specify a size, it's whatever size I specified. Okay, what have I done? I've done this top part. And I'm done with it. And I'm back to, you know, one level of indenting here in my source code. So whatever else I want to do, I can start right here. I can put a message there saying I'm done with command line argument processing. Okay, now I'm ready to do my hash initialization, open my database file, read it in, and so on and so forth. I'm going to write some bogus hash code. Okay, so there's our standard node, there's our hash entry, and I'm going to prototype some functions. So there's my hash init, and I'll make a bogus hash function called hash bogus that doesn't take any arguments and doesn't return anything, but I'm going to use it to demonstrate something. Actually, I'll do my hash dump. No, I'll just do a bogus one. Okay. So let's make some sample hash code. Okay, so this is going to be my hash.c file. I recommend putting all your hash functions in a hash.c. If your list functions are in separate files, that's okay, but it's easier to put all your list functions in a list.c and then have like a main.c or a plate.c, right? In terms of simplifying the make file, not having to jump around from file to file a lot. But also in terms of dealing with this global variable for the hash table size, it's a lot easier if all your hash stuff is in one file, hash.c. Okay, and your hash functions are relatively small because they're mostly wrappers around the list functions. Now, if you already have your list code from PA2 and you've got a separate file for list add and list print and list search, that's okay. That won't hurt anything other than make file size. But if you've already got pieces of your make file from PA2, that's fine. But I recommend putting your hash functions into a single hash.c file. And so I want to talk about this global variable business. So hash entry, hash init. So it takes a size and it returns an initialized hash table. And I'm not going to actually initialize a hash table. I'm just going to return a pointer to a hash entry. But here's the thing. When you call hash init, you tell it how big you want your hash table to be. Okay? Most of your other hash functions need access to that piece of information. Okay, anytime you call the hash function, it's got to know how big the hash table is because the last part of the hash function is reduce modulo hash table size. If you do your hash dump, which is supposed to go through and dump out the contents of your whole hash table, right, it's got a loop from 0 through the last element in your hash table array, and so on.
So what would be the benefit of like maybe passing it as like a parameter? These functions?
That would be the better way to do this, but I was trying to keep things simple, and I think I kept them too simple. So we got to live with a global variable. But normally we would pass the hash table itself and the size of the hash table, right? And the better way would be to make a structure that we call a hash table that contains the array and contains the size. But then it's starting to get, I thought, way too convoluted for what I'm trying to do here. So, but that's what we'll do when we get to objects, basically, in 223. All right, so I'm going to declare an integer hash size. I'm going to declare it outside of my function. So this is global within this file.
Since the default is 1,000, right, or 100?
100, yeah.
Yeah. So could you just say that's equal to 100, and then change it if you get an input?
I could do that, but it actually doesn't buy me anything because I'm always going to have to call hash init, right, to actually allocate the array, and hash init will get a size. But I feel personally like I want to initialize it to 100, but I'm forcing myself not to. So this is global within this file. So any function defined in this file can access this variable. But it's got to be the size of the hash table, right? Well, how do we do that inside here? Let's just save it as a global variable. I guess it's an uppercase S. Okay, so your hash init does the following. It allocates memory for an array of hash entries. It calls list init on each of those elements in the array to create a sentinel node for an empty linked list. And it saves the size argument in this global variable. Does that make sense? So my bogus hash function will say I need to loop over the hash table array. And just to make sure this works, I'll say size of the hash table array is, and we'll print out hash size. All right, so there's my whole hash package. And so plate, we've done all the command line processing, so let's call hash init, let's pass it the size that we want for the hash table. And then let's call hash bogus and make sure that hash bogus knows how big the hash table is. Alright, so if I don't specify an argument, hash bogus sees the size as 100. If I do specify an argument, it sees the size as whatever I passed in. Okay, that's the whole deal with the global variable. So it's just declared up here, and it gets its value when we call init. And then we can use it in the hash function or any of our loops.
Why are you adding a star before the table with hash entries already? When you find it, a star in?
Because it's actually an array of struct node stars.
Oh, it's like RGB.
Yeah, so it's a struct node star star. Right, but I'm thinking of a struct node star is just a hash entry. So it's an array of hash entries, or an array of struct node stars. Okay, yes?
Can you like access that global through code like you can in like C# where you could do like a hash dot name of the global variable?
You can get to it from other files if you say extern, right? Say that this variable is declared externally, then you can get to it.
What makes that different from a global?
It is a global.
But, so in,
It's just not as global as other globals.
yeah, but like, so if you do, you said in higher level classes like WSUB and stuff like that, they'd get mad at you for using
Yeah,
globals.
yeah.
Would extern change anything?
No.
Okay.
Yeah, it's still evil. Right. But
So the safe way is just to keep passing it to the function.
just keep passing it, yeah, and if you don't want to pass 50 things, make a structure that has 50 things, and you just pass that one thing of that type. And then get to C++ or Java, and it all goes away. All right, so good time to talk about .h files, right? Because in the beginning of my hash.c, I have a structured declaration and I have a typedef declaration. And in the beginning of main.c, or sorry, plate.c, I have exactly the same stuff, right? These first few lines I keep typing again and again. And so we're going to make, I'm just going to call it stuff. I'm going to make a new file that has those lines of code that I seem to keep typing. And it's a file in my current directory called stuff.h. And now inside main.c, instead of, sorry, plate.c, instead of typing in all this stuff, I'm just going to say include stuff.h. And inside my hash.c, I'm going to do exactly the same thing. Instead of typing all this stuff in, I'm going to say include stuff.h. And what that means is when I'm compiling this file, when it gets to where it says include stuff.h, it's going to pretend that all of this was typed right there. Okay, it's going to basically replace number sign include stuff.h with the contents of this file, stuff.h. The advantage in doing this is, one, my hash.c looks a lot cleaner now. And two, if I decide to change this structure, if I decide that I want to call a hash entry something else, or I want to add a new field to my struct node, I can change it in this one place, and every file that includes it effectively gets that change automatically. Right? So it minimizes the possibility of typos, it makes it easier to make updates and changes, and it keeps my code more devoid of these details, right? Yeah.
So we could on the list now.
If you're using that stuff, it depends what's in here. So typically I would define the struct node in here. I'm defining what a hash entry is. I would put in function prototypes in here. And all of that stuff, it's totally safe to include whether you use it or not. So yeah, you can put this in every file where you need to use any of that.
I think that's what we do with standard
Say again?
I think that's what we do with standard
This is what we do with standard I/O. We just don't necessarily think of it the same way. But when we say include standard I/O.h, that's saying replace that line with whatever is in this file, standard I/O.h. So quote stuff.h says look for stuff.h in my current directory. Angle bracket standard I/O says look for that in the system directory. Okay, but it's basically including a file with a whole bunch of stuff in it. Right, basically including all of this, so 1,000 lines of C code, which itself includes other things as well. So this is thousands of lines of stuff being pulled in. But it does stuff like prototype functions like printf and so on and so forth. All right, so I've got my include file in the top. All right, so let's talk about reading the database. So I've got bogus stuff going on here. Let's read the database. All right, so we need a few things here. So to open a file, we use fopen. Okay, fopen takes two arguments. The first argument is the name of the file we're opening. It can have slashes in the beginning, or it can just be a name that's going to look for in our current directory. Second argument says how are we opening it. If we say quote R, it seems we're opening it for read only, which is all we need to do with the database of license plates. But there's other ways we can specify that we want to open a file. And then fopen returns a pointer to a thing called a file, uppercase. It's defined in standard IO.h. But it's a typed F that's been set up for us, okay? And we don't really need to worry about what it is for here. It just returns a pointer to that. So we have to save that value in a variable. I'm using my variable fp, that's for file pointer, but you can call it whatever you like. And it may or may not succeed. Okay, FP is a pointer to a file, but if it can't open the file for reading, if it doesn't exist, if we don't have read access to it, if any other error occurs, it's got to let us know that it failed to open the file. It does that by returning a value of null. So first thing you want to do is make sure that you didn't fail. So if FP is equal to null, let's print out an error message. And let's return. So if I run this on database.txt, it looks like it worked fine. If I give it a file that doesn't exist, it'll give me an error message. So I won't start trying to read from a non-existent file and giving me bogus data. So let's read from the file. So let's make a character array. And let's use fgets. First argument is the string, second is the length of the string, third is what you want to read from. Standard in reads from the keyboard. fp reads from whatever file fp is associated with, which in this case is whatever argv bracket 1 is. So let's read from fp. And let's print out what we read. So if I do that, what did it read from fgets? It read the first line of our database file. Okay, so let's parse this input. So we want to break it up into a license plate, a first name, and a last name. Okay, so this is the one place that I said you can hardwire some string lengths. So we're just doing that in main. So how do we break up this thing that contains a license plate, space, first name, space, last name into 3 separate strings? It's a perfect job for sscanf. Alright, so scan temp, break it as 3% s's, those are strings separated by white space, store the resulting strings in plate first and last. %s matches up to a space and then it stops. So that should pick up the first 3 fields. Now if I didn't know if this was a good file, I would want to check the return value and make sure it's equal to 3. And if it's not, that would tell me there was something wrong with my database file. I don't think I asked you to do that. You can assume the database file is pristine. And so we know this will scan off 3 strings. And let's just confirm what it got. So let's just do a print statement. I'll put delimiters on my strings to make sure that there's no funny characters embedded in those. And so that looks good. And I'm using this exclamation mark to recall previous commands. If you type exclamation V, it'll rerun the last command that started with a V. Okay, so I know exclamation VI will do my VI, GC will do my compile, PL will do my plate. That's a little dangerous to use when you get tired, right? There's occasions where I've done exclamation R to recall some command and forgot that I had a moment earlier done an RM star in another directory I was getting rid of, and have like wiped out all my files with like 3 keystrokes. So it's a little potentially, right, but I'm not doing anything precious here right now. You can make a script that does your compile and execute and stuff like that, or you can up arrow, right? But I'll live dangerously for now. All right, so we can read a line of input, we can parse it into the 3 components. Let's put this in a loop, because really what we want to do is read a line from the file and then add it to our hash. Right, to add it to the hash, we're just going to call hash add, give it the hash table, the plate, the first name, and the last name. Well, we've got all those pieces already. We've got the hash table from hash init, we've got the plate, first name, and last name from our sscanf. So all we need to do is throw this into a loop and actually add the hash add call, which I don't have. So how do we loop? Well, this will loop. And that looks good until it gets to Julie, and then it just keeps adding that information to the database, and that's not good. All right, we're going to segfault for sure. So we need to know when it's reached the end of the file. Okay, it should stop. There we go. We need to know when it reaches the end of the file, and so fgets, right, gives us a flag when it reaches the end of the file by returning null. Okay, we've done this with standard in as well. So what we can do is, instead of looping forever, let's change our while statement to be the following. While fgets is not equal to null. Okay, we're doing three things in that line. We are calling fgets to read a new line from the file and store it in temp. And we're checking to see if that's equal to null, meaning we got into the file. And if it's not equal to null, we're proceeding into the body of the while loop while we'll do our parsing and our adding to the hash, right? Whereas if it is equal to null, we will kick out of the while loop. And we'll put a print message down here. Just to say we're all done with this. So now it reads the database, it pulls in everything, including Julie Horn at the end, and then it says all done reading the database. And if I run valgrind on this, I get a memory leak even though I haven't done any mallocs. And this was some head scratching this morning in my office, and I forget who it was, but he actually figured out what the problem was, which was new to me, which is if you do not close a file after you open it, valgrind will report it as a memory leak. Because when you open a file, the system needs to create memory space to store information about that file. That memory is released when you call fclose. If you don't close it, you'll get a memory leak. One that at least confused me for a long time.
So does the OS like not close it itself?
It will close when you exit, right? So all these memory leaks are really just kind of cosmetic. The concern about it, because the memory is freed when your program exits. But everybody always wants to make sure your program doesn't have any leaks, so we want to clean those up. So, well, we're done reading the database, so we call fp, fclose with an argument of fp. That closes the file, right, which lets you sleep at night, right, and it also releases the memory that was allocated. So now if we run it on valgrind, we get no leaks. All right, we have checked and processed the command line arguments. We've done hash init. We've opened the database file, read it in. We would have added it to the hash if I had a hash add function. Instead, we just printed it. We're done with all of this. Okay, we're ready to read user input, process it, and loop until the user says I'm done, and then just exit. And by the way, I'm still at my first level of indentation here, right? That's deliberate. I get confused if this was 3 or 4 levels indented, right? I got to keep track of why that is. So when something happens that causes me to want to exit, I just exit, right? And I know that if I get through this if statement, everything is okay, right? And I've set it up so that if argc is not 3, right, then I don't have to put all of this in an else statement, right? I've done what I needed to do in the case where argc was equal to 3. I've done what I needed to do in the case where argc was not 2 and it was not 3, and so on. Okay, so what's left? Read user input and process it. Okay, how do we read user input? We use good old fgets, right? So fgets from standard in, that will get a command. Whatever you get with fgets is going to have a new line at the end of it. Okay, that can trip you up. Now in here, when I was reading from the file, right, the things that I read with this fgets also has a new line at the end of it. But since we're using sscanf to break it into 3 strings, that new line is considered white space. It doesn't show up in this last name. But if I just say fgets, you know, a command from the user, that has a new line at the end. So that's where I'm suggesting you know, that thing that we did the other day where you remove the new line by setting temp bracket string length temp -1 equal to a null terminator, right? That'll chop off the new line. You don't have to worry about it anymore. Otherwise, you know, you look for a plate ABC 123 and it thinks you're looking for a plate ABC 123 \n and it never finds it. And you can spend a few hours debugging your hash function and it's just that you were looking for the wrong plate. So if you don't need the new line, right, I would say get rid of it right in the beginning. And now temp is one of the following. It's either star load, star dump, followed by a number, star dump without a number, or a license plate. Okay, how do we tell if it's star load? String compare. See if string compare temp, comma, quote, star load equals 0. Same thing if we want to know if it's exactly star dump. If we want to know is it star dump followed by a number, that's an sscanf thing. So if sscanf returns 1 when you look for the following pattern, star dump followed by a %d. So scan temp with a star dump followed by a %d. If it finds star dump space followed by a integer, it will return a 1 and the value of that integer will be in this variable num. So if it's equal to star load, do whatever you're supposed to do. Else, if it's equal to star dump, do whatever you're supposed to do. Else, if it's star dump followed by an integer, do whatever you're supposed to do. Else, look for a plate with the name temp. So call your hash find with temp, and if it returns a 1, print out the first and last name. If it returns a 0, say it's not found. Put that in a while loop while fgets is not null, and you've got your iteration where you're reading user input and processing it. When you kick out of that while loop because fgets returned null, call your free function and return. You're done. All right, last thing, when you're inside GDB, right, if you just run this, it's going to complain that I didn't specify a database. So you can say set arg, and you can specify what you want your command line arguments to be. So I can say set arg haha.txt, and then when I try to run it, it'll say cannot open haha.txt. So if you have a program that you need to run with command line arguments and you're trying to do it in GDB, this set arg will let you specify what the argument should be equal to. So I could say set arg /temp/database txt space 500, and it would run as if I typed in the 2 commands on the command line. Right? Or the easier way to do this is just hardwire the database name and the size in your main.c, right? Just temporarily disable the command line argument processing and just hardwire the stuff. It makes it faster to run. You don't have to type in database.txt and so on and so forth. Right? But if you want to do it from GDB, set arg is your friend. All right, is that helpful? All right, so keep working on PA3. Bring questions to class tomorrow. And we will start talking about cues tomorrow. And then we'll move on to trees, probably on Thursday.
Don't we understand?